Okay, let's start. Hi, everyone. Welcome to this month's webinar. And this is going to be about how to approach doing some API test planning. We're going to talk about the approach, talk about examples. I'm going to introduce you of one way of thinking about this is one strategy, which is SFDIPOT. If you're not familiar with it, it's something that is not API related, but it's just a way to think about things when you're doing testing, but also doing other stuff, product development. You do a lot of things with it. Yeah, so let's start. So I'm Gil, and I do webinars. But apart from that, I'm also a trainer and a consultant, and I work with people, developers and testers who want to make software better. Author the books. Apart from these webinars that I do like a monthly basis, there's also the YouTube channel, which I upload every week, something like that. A short video about all kinds of stuff regarding testing and development. So if you haven't checked it out yet, go there. Go there now. I'm going to mention a couple of webinars, past webinars that I did during this one, because although it's not a prerequisite to understand this webinar, you might find other cool tips to how to plan for testing there. I want to mention, because that's what I do. This is part of a whole lot of topics that go into my courses, especially for API testing, sorry, workshops that I do, both for developers and testers, but also for unit testing and stuff like that. So if you're interested in a workshop in your neck of the woods, let me know. I can help. So the first thing that we're going to talk about is the approach. And there was a client that I worked with in the beginning. What I did there is I worked with the developers who were developing the APIs, and they were testing their APIs, and asked them, how do you test that? How do you plan your test of execution? And they very proudly showed me an Excel sheet with a list of the APIs and a place to say if it's tested or not. So that's cool for API tests. But obviously we want more than that. And the approach that we probably want to use is looking at first from a feature perspective. So most of us are working from specs that have features. But the problem is that with features like that, they're vague. When we're talking about is something done, like we're going to talk about in our examples about meeting scheduling calendars. So if I told you meeting scheduling, you and I will have a different idea what that includes, even if we had the spec, because specs are never complete. What we really usually do is try to break this down into workflows. And if we do that, if we get a list of workflows, we could say, this workflow works. We kind of understand what it is. We kind of create this kind of the same picture in our heads of what is done, what is tested, what needs to be done, how it looks like. So we probably want to work at the workflow level rather than the feature level, just to make sure that we have a more complete and sort of equal understanding. Everyone understands what's the approach here, what's the goal. It's not that API tests are bad, the one that I mentioned before, either done by developers or testers. If you're working with Postman, you send something, you see that you got a 200. That's cool, but it probably won't let you sleep better at night. The reason is that API tests like that, like if you look at the result of or the static code, it's just like a unit test. If you think about it like that, unit tests are great, but and even if you have a lot of them, even better. But if you really want to sleep better at night, feeling the confidence that you know how the system works and how it behaves, you probably want bigger tests, not just the API test, the workflow test that we're talking about. So APIs by themselves are complex. We'll talk about that as well. So we can do all kinds of options of how to test them. And we'll see how that applies to what we need. But first, we need to connect them to the workflows they belong to. One more thing, if the APIs are the product, sometimes they are not. Sometimes they are like an interface between the user interface or the web interface or CLI to the system, and nobody sees them except the internal system, meaning the developers, so on. But sometimes they are the product. We expose these APIs to consumers, who the users will actually use them. So we need to be aware that the approach I'm going to talk about today applies, but it's going to be a little bit different. Because in terms of risk, we're exposing the APIs to users. They're not fully under our control. They can be called in whatever the user think of, and they can think of a lot of weird cases. What I told you is usually how we think. We think about features, we break them down into workflows. This is how the product should work. We should run the APIs in some orders. But because of the complexity, not just inherently in our systems, but also in the way APIs work, and they can be very complex, just throwing things on the wall works, but to an extent. It's not something that will help us feel comfortable that we thought about a lot of things. We will never think about everything, but a lot of things. So we probably need to think of a way to come up with idea. And that's true, by the way, for any level, not just the APIs, not just the API tests. For unit tests, it's the same. Even if you're testing a piece of the code, this piece of the code can be run in different ways, not just like throwing inputs and outputs out of it. So we need to be aware that, first of all, what we're talking about today is sort of a machine of how to come up with ideas. But it's not the whole process. After that, we need to do something with all the ideas that we have. So, and we're not finished with that, by the way. It's not like we're doing a meeting, documenting all the stuff that we come up with, and we don't think about it again. We'll come up with ideas later as well, and that's okay too, because that's how our minds work. A good point to start with is the top-level testing plan. This is something I discussed in other webinars, previous webinars. You might want to check it out. But a short review of that, it's a sort of document or whatever you have, how you document stuff, that has at least some of the ideas of what must work and what must continue to work. So even if you're thinking about new features that you haven't tested before, at least somebody has an idea of what must work here and what can work but not as important, and what must continue to work. And if you have done this kind of process, you're not starting from scratch. So if you go to YouTube or the website, you'll see the recording there. There's a template I used that you can download from there as well. So you can do that too. We need to remember that our approach lies on risk-based analysis. What is that? The fact is that we don't have all the time in the world, because if we had all the time, all the resources, all the people, no worries, we can test whatever we want, whenever we come up with it. But we don't. So that means that we need to approach a system in terms of testing with the goals of learning as much as we can on it, because our goal as testers is to learn the system, see how it behaves, report to stakeholders, different stakeholders, by the way, we'll talk about that as well, and let them decide what to do next. So in order for us to do this, we need to come up with as many ideas as we can, prioritize them, and there's an order that we usually work for, because let's say we come up with 1,000 ideas of testing. We don't have all the time in the world, unfortunately, so we need to prioritize. We said, like, okay, out of these things, 300 seem to fit into the time that we have. And only after we picked those, we start designing them, designing the tests. And this is something I'm not going to talk about today, but will probably be in a separate webinar. How are we designing the tests in order to learn what we want? So that's the order of things, like coming up with ideas, prioritizing, and then design. One more thing about this, it's not just about what we're doing, it's how we do it. And we probably want to collaborate with people on this, get as many people, smart people in the room, because the more people we have, more ideas we'll have, probably more good ideas. But I can't guarantee that. You'll have more ideas. So I said we're going to talk about a calendar meeting in an example. So this is like an example of a breakdown of a feature called calendar meetings. If I told you calendar meetings, you have different ideas in your head. Some of them maybe are on the screen right now, like schedule meeting, cancel unknown meeting. You're trying to cancel something that a meeting that wasn't scheduled, right? So some of you will say, this is like an edge case or negative case or something like that. But remember that, first of all, we are coming up with ideas. It doesn't matter with what kind of ideas relating and how they are relating to each other. And as a user, I would like both this scenario, both cancel a regular meeting and cancel unknown meeting, to work at least in the same quality. Okay, the product will decide what kind of quality we're talking about, but first, I'm seeing these things as equal. I want them to work because I haven't prioritized yet. In the same way, if they're working, they should work. So each one of them, we can break down, each case like this is workflow, we can break down into separate API calls. And I put it down here in a way that it fits in one screen. You can define your own details. But you already see that for a scheduling meeting, I'm not talking about just the post that creates the meeting, but also at least I'm going to do a get to see if the meeting was created. So it's a workflow. It's not just I'm checking that the post has worked, because I need to understand if the feature worked or the workflow worked. And for that, I need probably more than one API call. And you probably can see how can this fill up a whole wall or virtual wall, which is okay. That's the idea. So this is like something that we probably and naturally will do. The problem is that this is kind of a one-dimension thing. We're thinking functionality, what the system is doing, or what the user can do with the system. And we translate it into workflows, and we translate those into different API calls, which is okay, but it's not everything. And in order to think about other aspects, we need other tools to help us. By the way, I'm using visually here a mind map, which is like a set of tools. The different set of tools allow you to create different kinds of trees of what you see here is a tree, basically. And they can collapse. I use mind map, mindmap.com, but which is free. Unless for you go for a premium version, but it's a tool that you can use. Doesn't have to be a specific tool. You can also use Excel with a bit more than 2 columns, or Word, or whatever you use to document stuff. This is my first easy stuff, but Post-its work as well. So how do we do that? How do we come up with more ideas? Because there's a risk of sticking to this. the way our minds work is that we kind of lock on what we thought about. So, okay, we thought about this. These must be the important stuff, the important things that we want to check. And everything we add on it will probably be around these things. So the deal is, how do we expand our minds to enter more aspects? And the more what we have, we can think about, this may be interesting, not just for the user, but also for other stakeholders. So if you're not familiar with supercalifragilistics, it's not the only magic word out there. So SFDIPOT is a strategy. It's not the only strategy, but it's a strategy, a heuristic for testing strategy. And that's the main description that James and John Buck gave it to the people who created it. And it sounds funny, which is cool because it's easy to remember. And I'll show you in a minute what it includes. But basically, it's a heuristic. So what is a heuristic first? A heuristic is something that works empirically, successful, but not guaranteed to work. A valuable solution to a problem. It's basically what we call a best practice. Think about what you're thinking about best practice. If something was really best, it would be best for everything, right? But usually that's not the case. When we're looking for something new to learn, we're probably looking for something that worked for a lot of people in a lot of cases. That's a heuristic. So what we're calling best practice really is a heuristic. This is a heuristic, which means it works in many occasions to many people. It's not complete. It's a starting point, but it's a good starting point if we're going to come up with ideas. So what is SFDIPOT? It's this thing. And as you can see that they're sort of in order, but the order is only for saying this. There really is no item here that is more important than another, and which is good. And it means that you don't have to start with structure every time. And like I said, it's easy to start with functionality because these are the things that are already spec'd for us. We used playing with it, kind of approaching this functionality first, but really there's no order here. Also, once you come up with an idea, it really doesn't matter where it came from. You don't need to log it back to where it came from. It doesn't really matter. It's possible to come up with the same idea from different points of view. That's cool too. Doesn't matter because the goal is to have as many cases, workflows that we want to test. What are these things? So structure is how the system is built. Functionality, this is I already showed you an example of that. It's how it works, what it can do, what the capabilities are. Data is something that we usually associate with functionality. We combine them together, but you can, at least in the API world, you can have the same APIs sending different types of data, right? So it's how the system deals with data. And you can separate those, and you can have the same operations with different types of data. So separating these things allows us to say, okay, today or now, we're focusing on data. Of course, I'll show you an example of that, how you do this, and separating these things from another allows us to think, well, now we're focusing on that. Interface is how we interact with the system, but not only that. Platform is the environment of where it's running. And operation is the first thing you probably think about is like functionality, but it's not just functionality. Functionality is how the system works, but operation is how we operate it. Just not the same. We'll talk about that as well. And time is everything that it is related to. Time, frequency, concurrency. You can do a lot of, I come up with a lot of ideas about this. Okay, one thing to remember before we jump into the examples that I prepared is, first of all, remember that, first of all, you can apply this, like I said, in different levels. unit, API, UI, integration. This thinking, you can think about, well, I have these two modules that talk to each other, want to test them together. Let's think of different workflows or scenarios that we can test them. The second thing is that if it doesn't work for you, it's okay. Only functionality works and nothing, that's okay too. It's just a way to tell you, think about these things. Maybe you'll come up with ideas. And it's not complete. You'll probably think, and I'll talk about non-functional requirements at the end. A lot of the things like reliability or accessibility in UI don't cover that. You'll have to come up with ideas around this, but it's, like I said, it's a good starting point. So our example is around software that does meeting scheduling, and I'm going to start with functionality because we already saw that. This is, like I said, this is like the, I probably don't have to explain this, but it is the way we probably think. We understand we're the user, we're kind of playing some kind of step-by-step scenarios that we're going to do. Some of them have maybe more importance or more risk related, and that's okay. But remember, we're not doing prioritization now, we're trying to come up with ideas. Sometimes schedule meeting, for example, is something that is not only just posting and getting the ID, but also you're getting all the meetings. So you'll think about this, that in order to check that schedule meeting works okay, I need to schedule a meeting, I need to get the meeting, I need to see, to get all to see it there, and maybe even delete. How you're trying to fill the rubrics here, you don't have to fill everything, and you don't have to think about everything in advance, but the more you have, you can just put things in place. They may change later, you may change later, that's okay, but it's an idea. And it's also a visual way of thinking about this scenario, which is like this, but it isn't. Same for canceling an unknown meeting. Maybe I put in get and delete. So maybe delete cancels the meeting, but get is like a pre-step that I do before in order to check that the meeting is not there. I put it here because I was thinking about it this way. There's no one way to do this, or in terms of level of details of how much, but it helps to see the differentiation between different scenarios. And that's functionality. Let's talk about the other stuff that we might not think about. So first, structure. From now on, it's going to be by order, just because I don't want to mess you up too much. So what is structure? Structure means that I need to understand how the system is built, its architecture, its design, in order to test it. And that means that if you're coming from a black box idea, that means that if you have an API, you don't care what's happening behind it, how it's built, if it's one box, if it's 3,000 boxes, if there's a database, there's no database, if it's files or whatever, you don't care about it because you're testing the API. However, if you knew how things are built, then it opens up the opportunity to check things either working as you expect or learn how it does. So for example, let's say we have a distributed system and the API as a server and a business layer and a data layer and a database, like 3 or 4 things. So if I told you that the system is working like that, you'll say, well, what if the database can be disconnected? Now, if I didn't know how it looks like, I would say, well, I don't care. I probably not try to design a test that says, okay, I need to see something that I'm coming in with scissors and cutting the wires. What happens? How does the system behave if the database is disconnected? What happens if the web server doesn't work? Is what I'm seeing on the screen what I'm expecting to see as a user? So if the server is unavailable, I get a 500, maybe. Is that good? Not sure. Maybe it needs to be something different, like showing something in server unavailable on the screen without the 500. So things can change if I know how things are working, but also on the other side. So if I'm doing a scheduled meeting, at the end, I'm expecting an invitation to be sent. Okay, what happens if the system cannot send the invitation because of how it's built and something is disconnected or doesn't answer? So we can ask the questions and see how things work. But it's a bit more than that, because it kind of leaks into test design, which I'm going to talk about for a second on the structure, but like I said, it deserves a whole webinar about it. So let's say that you have this distributed. This is how the system works. It's a distributed system and so on. But you would like to learn more. What is more? Tests allow us to know how, if the system works the way we expect it, or we learn how it works by doing stuff. But it also leads us in a way to, if there are surprises, not even bugs yet, but things that are weird. We use these tests for debugging. We use these tests for understanding of what went wrong, or how does it actually work. The problem with a system like this, it is already complex. So if I knew that our system is distributed, I'd ask, okay, I want to learn if my code works, the code that we develop here. Now, if I do that, I said, okay, so how do I learn if my code works? And this is how I can design the same set of tests running on a single box, with no authentication, in-memory database, no, everything's on the same box, no disconnects, things that I can assume that will work. And now I have something interesting, because if I have two sets of tests running on the real system or my one-box system, if both tests are running and passing, excellent. But if tests are failing on the real system or the pre-production testing environment, this distributed one, and the same tests pass on the one box thing, then we know there is something wrong with the rest. Configuration, environment, whatever. And that allows me to, I can say, learn and understand the system better, but I can also do something about the failures. So like I said, looking at the structure allows us to even change the structure in order to learn more, which is interesting. Okay, so we can play with structure a lot, and we can, but let's move on to the other stuff as well. So data. So if I want to export a meeting, I can do this with one API called get. It returns to me a JSON, for example, and then I can export that to different scenarios. This is what it says in the spec. I can export meeting data to XML, JSON, or whatever calendar else we can do. So this is like a very simple example of how data is something that's very tied to functionality, but you can do the same functionality with different things. Sometimes we think about exporting to XML and exporting to JSON as two different functionalities, which is okay. So, but this is like the same functionality with different sets of data. So a lot of things, we can think about these things as, if our system is very big and we got inputs coming in and outputs coming out, we can think about the inputs and outputs, all kinds of sets of data, and play with that. But we're talking APIs. So with APIs, we can do a lot of other things that are data related and see how they're working. So if the schedule meeting workflow includes the post and the get, I can play with different headers. Like if I create a meeting, sending a JSON or sending XML is something that I can play with. And I can play with different headers, missing headers, add headers, headers that tell me that authenticate me, headers that authenticate me as something else. And this is just having being built on known protocols gives me enough power to play with different things. Not all of them I need to send, but these are ideas that I may or may not want to check. But even if the body, I'm sending like JSON. uh, What if I send a JSON that is, first of all, not valid? I don't close it. How does the system behave? Maybe it is valid, but is it completely different schema of what the system wants or expects? And then there are fields, optional fields, missing fields. If I send the same fields again, how does the system react? Obviously, in coding in international characters, I can, but I'm using REST APIs, which are built on HTTP. Basically, these are text-based. I can do with text whatever I want. If I'm looking for other protocols, binary protocols, gRPC, for example, it's binary. I can send bytes in whatever order I want. I might not do that. The user might not do that, but maybe they will. And I want to see how the system reacts to that. So think about everything that's coming in, everything that's coming out, things that you're interested to learn. If things are changed, what is the impact on what we see? Interface is how we interact with the system. So API is usually an interface. It says so in the name. And so obviously you interact with APIs by invoking the APIs. I know, shocking. But you could do it directly. You could do this from the user interface. You do this from a mobile app, and each one can call the APIs in a different way, different headers, maybe repeatedly, maybe not repeatedly. So first of all, think about how you're going to do this. CLI means that there's at least going to be one translation layer. UI also, that means translating from the front end to something. So first of all, I think about API, not just calling the API itself, but if there's someone calling or another layer calling it, it's interesting to see what are the differences, how it calls it, and what happens when they call it, and what's the impact of that. So first, keep that in mind. But interfaces is not just how we call our system, it's also what happens in the backend where the system calls other system. So for example, if you think about, well, I'm scheduling a meeting, right? I left that from the structure thing, but it also has an impact, of course. What's the response time? Think about calling an interface is something of not just if it works, but also of an experience. So how long do I have to wait for the meeting to get scheduled? Okay, it could be translated into response time. Think about if you ever played a game and you kind of clicking on stuff on the screen and wait for things to happen. This is an interface thing. It could be an API issue. It could be like a UI issue. It could be a server thing. It doesn't matter. But when you do this, you check also the experience of what happens when you wait. Sometimes the experience is, okay, it takes 100 milliseconds, that's okay. Sometimes you're playing a game and 100 milliseconds is a lot. So you can think about like even response times and the experience that results from that, but also think about the server and we're sending out invitations, right? Are they sent? What happens if you're trying to send, or the system is trying to send the invitations, but nobody answers? Does it send something again? Does it retry? Does it return something in another API about the status that tell you that something went wrong? What happens when you're trying to talk to another system and you try to invite someone who is not on our system or their system? Something that happens on the boundaries of our system, it usually falls into the interface. So you probably want to think about, if you come from some minimal experience with domain-driven design, we talk about the system and its boundaries. So whatever boundaries we're talking about and things that happen on the boundaries is thinking about it. It's not something that we always see on the screen or the logs. Want to mention an honorable mention of some of the new guys that have joined us in the recent years, which is our AI guys. So this is an interface. What you're seeing on the screen is a sort of an API that will tell an LLM agent, large language model, it will send this text, and this text will be translated somehow to a meeting, right? So it's an interface, and it's a very interesting interface because it's not deterministic. It will not give you the same examples or same requests or same results every time the same. It is open for interpretation. It is interesting to see how these things works, and you probably if you have like an interface that gets an API that you send in free text like that, you open up a whole bucket or pit, depending on where you come from, of ideas and snakes that you can play with and learn how the system reacts. And the fact that it's probably not going to be the same result tomorrow as it is today makes it even more interesting. So if you're working with AI and statistical data, whatever your system is not repeatable, or you need to be aware of that. Some of it comes at the boundary level, like this thing. Okay, platform. Platform is usually we're thinking about, okay, so can we run this on different boxes? One of Windows does it, what Linux does it behave the same? That's the usual canonical example that we think of, and it's easy to explain. People understand that, and that will tell you that you can run this server both on Linux and Windows, or just on Linux, which is usually not that interesting. But you can expand that to think about other things. First of all, the components. We know that what we're running is not running just our code. In fact, our code is like a very small piece of what we're running. We're running web servers, we're running environments, OSs, different servers that we interact with, all kinds of things. But related dependencies like JDKs, SDKs, libraries that we work with, all these we depend on them. And if we just replace them, not just the code changes, but could be a lot worse. If we upgrade them, maybe there's going to be a problem. They stop working. Today in security, we're talking a lot about attacking the supply chain. That meaning that if you want to hack a system, not that you do, but if you're writing a system that is built on dependencies, it is easier to build a hack to one of the dependencies that you bring into your system. And we had examples like that recently. So this is kind of opening a whole bunch of cases of what is the relationship between our software and its dependencies, and what does it mean in terms of test cases, stability, reliability, stuff like that. But you can go a bit more deeper here. So the same APIs, you can talk about, well, I'm going to run this against an embedded system, a watch. Does it work the same as it's running with the web server? So you think about, it's from interface. Okay, but what if the server runs on the watch? So working with embedded systems means you usually have limited memory, limited disk space, limited storage. So running the same application on different devices, let's call it, it's not just an interface issue, it's behavioral issue, it's performance issue that you might want to be examining. Even taking it a bit like, let's get back to our distributed example. I know there's usually not a thing like a full database, like database that got full. But there are instances where we're getting closer to that. How does the system react when it's getting slower to find things? Data is distributed. How do we find what happens when we don't find things immediately? We can run different sets of APIs, different versions of API side by side. What happens when we do that? It's not just operating the APIs in a certain order now. We can interrelate the different versions, call different versions in a certain order and see what happens. So that and having backward compatibility even for the APIs themselves. So platform can be expanded to a lot of things that we usually don't think about unless we think about it. Somebody thought about it before. We just say, okay, platform is everything outside our code. And all these things run together, what kind of an impact does it have? The environment, our dependencies, and so on. Operation. So I said it's kind of, we usually think about these things as like functionality, but it's more than that. Let's say that you can run, you have like admins in the system and regular users, and regular users cannot do what the admins do. In terms of API, this means that there's a two-way we would like to test that. First of all, like in the first instance, both users and admins can delete meetings, but the users, they don't delete it. It's marked as undeleted, while the admin actually deletes it. So same API, different users operate in a different way, so functionality changes or the impact is changed. But also look at like admin APIs like delete all or get all that the user can do. Well, they can do. What happens when they do call these APIs? It's interesting to see. Sometimes it's very interesting to see. So we have expectations of how same functionality can or APIs can be called by different roles in the system. And we want to see that our expectations are correct, even if things are crossed. It's not just admins. Things can run automatically in the system. Jobs that run in the middle of the night and like backups and stuff like that. They're calling APIs just as before, so we want to see if the APIs work and who's running them and can anyone run them and so on. We're also interesting, like you think about like a backup that you're running, regardless of how it's done, like replication or downloading or whatever. What happens when you're running this? Is the system locked? Is the system still functioning? Is it functioning slower than before? This kind of opens up, like if these things are running, and these are operational things, what is the impact on the functional stuff? Interesting to learn. The final thing that we have in SFDIPOT is time, which is kind of a very big bucket of a lot of things that are related to time, frequency, concurrency, all kinds of things. So think about scheduling meeting. What you see on the screen first are application-specific things that are related to time. What happens if I try to schedule a meeting in the past? What happens when I'm scheduling meeting to the at the same time, like overlapping? You can say, "Oh, this is functional. You can't schedule a meeting in the past." Okay, or this is data. Okay, too. Doesn't matter when you came up with the idea, as long as you did. What happens? This is like I had to think about this a bit more deeply. What happens if you you schedule a meeting and immediately after that delete it? Okay, so immediately just calling the APIs immediately after that. But there could be cases where the invitations will not be sent out. And it could be that they are sent out, but they are not accepted, or they are accepted, but they deleted that. So all kinds of scenarios that are under the umbrella of is it happening very fast can happen just when you think about, well, it's not just a series of options, but there's a time distance between them that you probably want to see. What happens if we squeeze this out? What happens if I schedule a meeting for now? Does it work? One more thing that we don't have it that I just thought about. What happens if you're starting to schedule a meeting, but you haven't pressed schedule yet? So you keep your computer, your browser open for 24 hours. What happens then? It's interesting. Okay, so this is a system view rather than an API, but maybe it can be translated to starting a meeting so the data will be saved, so you won't have to start from scratch all over again and stuff like that. Halting things in the middle also falls in the bucket of time. What do we have here? All things that are related not just for the application, but the outside world, the special dates. Like these are like the canonical things. What happens on February 29th, or when you're switching from daylight saving time on and off. Especially when you're switching outside of daylight saving time, basically you can schedule 2 meetings to the same time or twice. What happens then? Time zones. What happens if you happened a lot to me? You schedule something on one time zone, review it in another. What will happen? What happens if your attendees are in multiple different zones? Do they see the data correctly? What happens when 2 people are trying to schedule a meeting with the same invitees at the same time? What happens when 1,000 people do that at the same time? So time, concurrency, frequency, all these are like things that the starting point time will help you think about what happens. Things happen very fast, very slow, at the same time, almost at the same time. The order of stuff, things that we usually don't think about when we talked about the other stuff. And as you can see, that it brings out a lot of aspects that we are not trained to think about. And this is the whole idea here. Right? The whole idea is to give you starting points to think about, well, what is interesting here? At the end, you come up with this unreadable thing. This is just the things that we talked about today. But obviously, it will be a lot more bigger, so you'll need a bigger wall. Are we done? Well, no. First of all, like I said, it's not a complete process. It never is. First of all, it gives you idea of starting points. You think about ideas, and you come up with others. But there are things that we don't have starting points in SFDIPOT because we ran out of letters. Non-functional requirements. I did a whole webinar about non-functional requirements. Security, performance we touched, accessibility, repeatability, reliability, all kinds of things. We can expand these things to think about cases that are interesting for us. Some of them are, we just need the push. Like, think about performance. We did that last year. But security, you're doing it for the first time. Where do we start? It's a whole new world out there. Might do something about it in the future. Tell me in the chat if you're interested. So it's a process. It doesn't stop here, but at the end of this meeting, you'll have at least a list of ideas that you can start working with. Also, I didn't talk about exploration. I kind of mentioned it in other words, which is learning about how the system works, but this is like planned learning. You come up with an idea and you say, it's interesting to learn how this thing works. You put it in the list, and at some point you'll try to explore it. What we usually call exploration testing, exploratory testing, is that, but at a small scale. It means that you're doing stuff manually and or semi-manually and see what happens, and then you react to that. Usually that's not really planned. You say, like, usually in the exploratory testing, also a session that you can have on the YouTube channel, you can watch it there, is you think about areas, ideas, whatever you want, and you work around that once you get to testing. You can't plan exploratory too much because the exploration is being done on the job, but you can come up with ideas that you can tear from what we thought about this year and this list and say, these things I'd like to explore. The next step that you have, right, like repeating the things that I told you at the beginning, once you have a set of ideas, a big list, you need to prioritize and say, these are the things that are important for us more than others. If we have time, maybe we'll get there, but we won't have time, so at least we start with these things and see what happens. We'd like to see that things are working the way we expect. The things that we don't expect, we'd like to see how they are working and learn more about the system. And you prioritize, and then you design your tests in a way that will help you reach the goals of what you're actually doing, are you looking for. What I showed you, it's kind of a considered a testing activity, but if you're working with the developers or you are the developers, good for you to know these things. Work together, collaborate. More people with more aspects with more perspectives can bring more ideas to the table. And finally, this is not a one shot. You can do this on different levels of a release level, a sprint level, short amount of time, short amount of work that is planned for a sprint, and you can do the same thing. The amount of testing that you can do and will come up with is probably shorter than in something in a release, hopefully. And but again, it's a good idea to have at least a way to understand that this is how this thing works for a lot of people. This is what I wanted to share with you today. So first of all, thank you for staying with me. If you have questions, put them in the chat or the QA box, wherever it went. If you're interested in one of my workshops, let me know either now or Gil at Testing Gil. These are ways to come in contact with me. Want to mention again the YouTube channel when we have the webinar recordings, other YouTube videos that I do around these things. Thank you very much and have a very nice rest of the day.